Okay, we're going to evaluate the integral x square root of x plus 5 dx. Okay, this is not as bad as I was making it out to be last night. Because we were talking about a u substitution. Okay, we want to let u equal x plus 5. Okay, we got that far. U is equal to x plus 5. And now we want to find the derivative of u with respect to x. Okay, we want to find the derivative of u with respect to the variable that we have there, x. So du dx. Okay, the derivative of this, the derivative of x is just 1. Okay, the derivative of 5 is 0. So du dx is equal to 1. Okay, we really want to have du all by itself. So we're going to multiply both sides times dx. Okay, because we want du all by itself. Okay, so that leaves us with du is equal to 1 dx. And really 1 dx just means dx. So these are the important things we're going to use to do a u substitution. And remember the goal. The goal is to get all of our x stuff. It's all x's now. We want to turn everything into this problem in terms of a different variable u. Let's just start doing this. This isn't as bad as I was making it out to be last night. Okay, since u is equal to x plus 5, okay, that x plus 5 right there is u. So this chunk of the integral is square root of u. Leave a bunch of room there. I'll show you why in a minute. Okay, this dx can be replaced because this dx is simply du. Okay, the only thing that was kind of funky was this x. I got to get rid of that x. Okay, it's still there. And it's really simple. All I need to do, if I want to get rid of that x and name it in terms of u, I can take this u is equal to x plus 5 equation and simply solve it for x. If u is equal to x plus 5, but I want that lonesome x to be stuffed with u's in it, okay, I can take that u is equal to x plus 5. I can solve it for x by subtracting 5 from each side. So u minus 5 is equal to x. Okay, so that x sitting there, I can change that to u minus 5. I better put parentheses around it because it's going to be multiplied to the square root of u. Okay, look at what we have here. We now have an integral with everything turned into u stuff. Just took a little extra work with playing with u is equal to x plus 5. Okay, so I just need to find the integral of this. It would be easier to do this problem, in my opinion, if you changed u, the square root of u to u to the 1/2 power. So I have u minus 5 times u to the 1/2. Okay, to solve this problem, I want to get rid of those parentheses because I really want just a bunch of terms, things added or subtracted together. I don't like that multiplication stuff going on. So I'm going to use the distributive property. I'm going to take u to the 1/2 times u, and I'm going to take u to the 1/2 times negative 5. Okay, u to the 1/2 times u to the first. Now when you multiply a power times a power with the same base, you add the exponents. So u to the 1 plus 1/2 is 1.5. I'm going to go ahead and write 1 plus 1/2, 1.5 as 3/2. Okay, u u to the 1/2 times negative 5 would be negative 5 times u to the 1/2 du. Okay, now I have just things added or subtracted together. That's so much easier to find the integral of. So I have u to the 3/2 minus 5u to the 1/2. So let's just go ahead and integrate this. Okay, u to the 3/2. Okay, the integral, I need to take 3/2 and add 1. So 3/2 plus 2/2. 3/2 plus 2/2. That'd be u to the 5/2. Okay, now you could divide by 5/2. We talked about this yesterday. I could put that over 5/2 if I wanted to. But maybe, at least for this kind of problem, it's easier to think of it as 1 over 5/2. 1 over 5/2 in front. But 1 over 5/2 is really just flipping that over to 2/5. Okay, so that's 2/5 u to the 5/2. Okay, minus 5. Just keep that constant. And now find the integral of u to the 1/2. U to the 1/2, add 1. Okay, 1/2 plus 2/2 would be 3/2. Okay, now instead of dividing by 3/2, I could think of it as 1 over 3/2. Okay, but 1 over 3/2 is basically just flipping it to 2/3. Okay, so I have negative 5 times 2/3 u to the 3/2. Okay, I can now simplify a bit. Oh, I really should have put plus c at the end. Okay, so I have 2/5 u to the 5/2. I can multiply here. Negative 5 times 2/3. Okay, just multiply the numerators. Negative 10/3 u to the 3/2. Okay, plus c. Okay, this is really, really, really messy. Okay, but this is correct. I just have one last step to do, is I did find the integral. All I have to do is every time I see a u, I'm going to replace every u with x plus 5. So my final answer is 2/5 times x plus 5 to the 5/2 minus 10/3 times x plus 5 to the 3/2 plus c. That would be the final answer. Okay, please let me know if there's anything that I've said in this video that doesn't make sense, that you just want a little bit more help on. Okay, we don't have to get on the website. We can hop on a Zoom meeting, because I want to make sure you understand the things that I kind of messed you up with last night, Joseph. Okay, please keep me posted. I want to help you if you need any help at all.